Rockwell B-1 Lancer. The Rockwell B-1 Lancer is a supersonic variable sweep wing, heavy bomber used by the United States Air Force. It is commonly called the Bone, from B-1. It is one of three strategic bombers serving in the U.S. Air Force fleet along with the B-2 Spirit and the B-52 Stratofortress as of 2022. The B-1 was first envisioned in the 1960s as a platform that would combine the Mach 2 speed of the B-58 Hustler with the range and payload of the B-52, and was meant to ultimately replace both bombers. After a long series of studies, Rockwell International, now part of Boeing, won the design contest for what emerged as the B-1A. This version had a top speed of Mach 2.2 at high altitude and the capability of flying for long distances at Mach 0.85 at very low altitudes. The combination of the high cost of the aircraft, the introduction of the AGM-86 cruise missile that flew the same basic speed and distance, and early work on the stealth bomber all significantly reduced the need for the B-1. This led to the program being cancelled in 1977. After the B-1A prototypes had been built, the program was restarted in 1981, largely as an interim measure due to delays in the B-2 stealth bomber program. This led to a redesign as the B-1B, which differed from the B-1A by having a lower top speed of Mach 1.25 at high altitude, but improved the low-altitude speed to Mach 0.96. The electronics were also extensively improved, and the airframe was improved to allow takeoff with the maximum possible fuel and weapons load. Deliveries of the B-1B began in 1986 and formally entered service with Strategic Air Command, SAC, as a nuclear bomber that same year. By 1988, all 100 aircraft had been delivered. With the disestablishment of SAC and its reassignment to the Air Combat Command in 1992, the B-1B was converted for a conventional bombing role. It first served in combat during Operation Desert Fox in 1998 and again during the NATO action in Kosovo the following year. The B-1B has supported US and NATO military forces in Afghanistan and Iraq. As of 2021, the Air Force has an inventory of 45 B-1Bs. The Northrop Grumman B-21 Raider is to begin replacing the B-1B after 2025. All B-1s are planned to be retired by 2036. Background: in 1955, the USAF issued requirements for a new bomber combining the payload and range of the Boeing B-52 Stratofortress with the Mach 2 maximum speed of the Convair B-58 Hustler. In December 1957, the USAF selected North American Aviation's B-70 Valkyrie for this role, a six-engine bomber that could cruise at Mach 3 at high altitude, 70,000 feet or 21,000 m. Soviet Union interceptor aircraft, the only effective anti-bomber weapon in the 1950s, were already unable to intercept the high-flying Lockheed U-2. The Valkyrie would fly at similar altitudes, but much higher speeds, and was expected to fly right by the fighters. By the late 1950s, however, anti-aircraft surface-to-air missiles, SAMs, could threaten high-altitude aircraft, as demonstrated by the 1960 downing of Gary Powers' U-2. The USAF Strategic Air Command, SAC, was aware of these developments and had begun moving its bombers to low-level penetration even before the U-2 incident. This tactic greatly reduces radar detection distances through the use of terrain masking. Using features of the terrain like hills and valleys, the line of sight from the radar to the bomber can be broken, rendering the radar, and human observers, incapable of seeing it. Additionally, radars of the era were subject to clutter from stray returns from the ground and other objects, which meant a minimum angle existed above the horizon where they could detect a target. Bombers flying at low altitudes could remain under these angles simply by keeping their distance from the radar sites. This combination of effects made SAMs of the era ineffective against low-flying aircraft. The same effects also meant that low-flying aircraft were difficult to detect by higher-flying interceptors, since their radar systems could not readily pick out aircraft against the clutter from ground reflections, lack of look-down/shoot-down capability. The switch from high-altitude to low-altitude flight profiles severely affected the B-70, the design of which was tuned for high-altitude performance. Higher aerodynamic drag at low level limited the B-70 to subsonic speed while dramatically decreasing its range. 9. The result would be an aircraft with somewhat higher subsonic speed than the B-52, but less range. Because of this, and a growing shift to the Intercontinental Ballistic Missile (ICBM) force, the B-70 bomber program was cancelled in 1961 by President John F. Kennedy, and the two B-70 prototypes were used in a supersonic research program. Although never intended for the low-level role, the B-52's flexibility allowed it to outlast its intended successor as the nature of the air war environment changed. The B-52's huge fuel load allowed it to operate at lower altitudes for longer times, and the large airframe allowed the addition of improved radar jamming and deception suites to deal with radars. During the Vietnam War, the concept that all future wars would be nuclear was turned on its head. And the Big Belly modifications increased the B-52's total bomb load to 60,000 pounds, 27,000 kilograms, turning it into a powerful tactical aircraft which could be used against ground troops along with strategic targets from high altitudes. 12. The much smaller bomb bay of the B-70 would have made it much less useful in this role. Design studies and delays. Although effective, the B-52 was not ideal for the low-level role. This led to a number of aircraft designs known as penetrators, which were tuned specifically for long-range low-altitude flight. The first of these designs to see operation was the supersonic F-111 fighter bomber, which used variable sweep wings for tactical missions. A number of studies on a strategic range counterpart followed. The first post-B-70 strategic penetrator study was known as the Subsonic Low-Altitude Bomber, SLAB, which was completed in 1961. This produced a design that looked more like an airliner than a bomber, with a large swept wing, T-tail, and large high-bypass engines. This was followed by the similar extended-range strike aircraft, ERSA, which added a variable sweep wing, then en vogue in the aviation industry. ERSA envisioned a relatively small aircraft with a 10,000-pound, 4,500 kilograms, payload and a range of 10,070 miles, 16,210 kilometers, including 2,900 miles, 4,700 kilometers, flown at low altitudes. In August 1963, the similar low-altitude manned penetrator design was completed, which called for an aircraft with a 20,000-pound, 9,100 kilograms, bomb load and somewhat shorter range of 8,230 miles, 13,240 kilometers. These all culminated in the October 1963 Advanced Manned Precision Strike System, AMPSS, which led to industry studies at Boeing, General Dynamics, and North American, 22. In mid-1964, the USAF had revised its requirements and retitled the project as Advanced Manned Strategic Aircraft, MSA, which differed from AMPSS primarily in that it also demanded a high-speed high-altitude capability, similar to that of the existing Mach 2 class F-111. Given the lengthy series of design studies, Rockwell engineers joked that the new name actually stood for America's Most Studied Aircraft. The arguments that led to the cancellation of the B-70 program had led some to question the need for a new strategic bomber of any sort. The USAF was adamant about retaining bombers as part of the nuclear triad concept that included bombers, ICBMs, and submarine-launched ballistic missiles, SLBMs, in a combined package that complicated any potential defense. They argued that the bomber was needed to attack hardened military targets and to provide a safe counterforce option because the bombers could be quickly launched into safe loitering areas where they could not be attacked. However, the introduction of the SLBM made moot the mobility and survivability argument, and a newer generation of ICBMs, such as the Minuteman III, had the accuracy and speed needed to attack point targets. During this time, ICBMs were seen as a less costly option based on their lower unit cost, 25, but development costs were much higher. Secretary of Defense Robert McNamara preferred ICBMs over bombers for the Air Force portion of the deterrent force and felt a new expensive bomber was not needed. McNamara limited the AMSA program to studies and component development beginning in 1964. Program studies continued. IBM and Autonetics were awarded AMSA Advanced Avionics Study contracts in 1968. McNamara remained opposed to the program in favor of upgrading the existing B-52 fleet and adding nearly 300 FB-111s for shorter range roles than being filled by the B-58. He again vetoed funding for AMSA aircraft development in 1968. Overview: the B-1 has a blended wing body configuration, with variable sweep wing, for turbofan engines, triangular ride control fins and cruciform tail. The wings can sweep from 15 degrees to 67.5 degrees, full forward to full sweep. Forward swept wing settings are used for takeoff, landings and high-altitude economical cruise. Aft swept wing settings are used in high subsonic and supersonic flight. The B-1's variable sweep wings and thrust-to-weight ratio provide it with improved takeoff performance, allowing it to use shorter runways than previous bombers. The length of the aircraft presented a flexing problem due to air turbulence at low altitude. To alleviate this, Rockwell included small triangular fin control surfaces or vanes near the nose on the B-1. The B-1's structural mode control system moves the vanes and lower rudder to counteract the effects of turbulence and smooth out the ride. Unlike the B-1A, the B-1B cannot reach Mach 2 plus speeds. Its maximum speed is Mach 1.25, about 950 miles per hour or 530 kilometers per hour at altitude, but its low-level speed increased to Mach 0.92, 700 miles per hour, 1,130 kilometers per hour. The speed of the current version of the aircraft is limited by the need to avoid damage to its structure and air intakes. To help lower its RCS, the B-1B uses serpentine air intake ducts, CS duct, and fixed intake ramps, which limit its speed compared to the B-1A. Vanes in the intake ducts serve to deflect and shield radar returns from the highly reflective engine compressor blades. The B-1A's engine was modified slightly to produce the GEF-101-102 for the B-1B, with an emphasis on durability and increased efficiency. The core from this engine was subsequently used in several other engines, including the GEF-110 used in the F-14 Tomcat, F-15K/SG variants and later versions of the General Dynamics F-16 Fighting Falcon. It is also the basis for the non-afterburning GEF-118 used in the B-2 Spirit and the U-2S. The F-101 engine core is also used in the CFM56 civil engine. The nose gear door is the location for ground crew control of the auxiliary power unit APU, which can be used during a scramble for quick starting the APU.